Welcome back, everyone. We're going to be solving LeetCode 347, top k frequent elements. So we're given an integer array nums and an integer k. We need to return the k most frequent elements, and we can return them in any order. So if we take a look at example 1, they give us an array of 3 1s, 2 2s, and 1 3 with the integer k, and then they give us an output of 1 and 2. Why? Because 1 occurs 3 times, which is the most frequent element in this array. 2 occurs twice, which is the second most frequent element inside of this array, and then we can just return the 2. But taking a look at the follow-up question down here, they tell us that we have to have an algorithm with a time complexity better than O of n log n, right? Because we could just create or just grab all the counts inside of this array with a dictionary, sort the dictionary by value, and that will give us the elements in order of frequency, right? And then we could just take however many we need to fill an output array, right? That would give us an O of n log n runtime, but we need to do better. How can we do better? We can use an algorithm called bucket sort, where we will have an array of a bunch of buckets, and these buckets are going to represent the count or the frequency of the number. So number 1 occurs 3 times, right? We'll have a bucket at index 3, which will represent every number that occurs 3 times, and so on and so forth for all of the numbers inside of our array. So we're also still going to need a count dictionary, so let's use a counter. We'll say from collections import counter. We will say our counts are going to be equal to the counter of nums, and our buckets are going to be equal to an empty array, and inside this array we are going to have a bucket for every index in range length of nums plus 1. So let's print this out to see what we have. We'll print out counts, and we will print out buckets. We'll run this, and we can see 1 occurs 3 times, 2 occurs twice, 3 occurs once. And as we can see in example 1, that is correct. We have a bucket array with 1, 2, 3, 4, 5, 6, 7 buckets. So what do we do now? We want the buckets to represent, right, the counts. So this bucket is at index 0. We need all of the elements that occur 0 times will go in here, right? So this bucket's always going to remain empty. Bucket 1 is going to represent the number of elements that occur 1 time. So what elements occur 1 time? Only 3 does, so 3 would go inside this bucket. So on and so forth for the other numbers in our counter. So how do we get that functionality? Well, we can say for the number and count in our counts.items, we are going to say buckets of the count dot append whatever number is there. So now we can print out our counts and our buckets to see what we have. And there we go. Position 1 has the value 3, right? 3 occurs 1 time. The position 2 holds the value 2. 2 occurs twice. Position 3 has the value 1. 1 occurs 3 times. Okay, so now all we need is an output array, and then what we can do is just loop backwards through this. Since these buckets are sorted by count frequency, right, we just grab all of the items inside of each one of these buckets until our resulting output is equal to the length of k. So we'll say result is going to be equal to an empty array. I'm also going to use a pointer for this, so we'll say pointer is going to be initially set to the length of buckets minus 1. Right, we're going to start at this last index. If there's any numbers in here, we're going to take those numbers, put them in this resulting array until the length of this resulting array is equal to k. So we're going to need a while loop. We'll say while the length of res is not equal to k. First thing we're going to do is check, okay, well, is this array empty or non-empty? So we'll say if buckets at our pointer position, if the length of that is equal to 0, right? If it's equal to 0, we can't do anything, right? So all we would do is decrement our pointer by 1 to move on to the next bucket. So we'll say pointer minus equals 1. Otherwise, if there are items inside of this bucket, we just have to loop through all of the elements inside of the bucket and put them into our resulting array. So we'll say for item in buckets pointer res.append the item. And then afterwards, we can decrement our pointer by 1. And then once we exit this while loop, we should have a resulting output equal to k, so we can just return res. So let's run this. And it does pass both test cases, so let's get rid of these print statements as well. And then we will run this, submit it. Perfect, it does run. Time and space complexity. Bucket sort does have a time complexity of O of n and a space complexity of O of n as well. So we successfully solved the problem and the follow-up as well, right? We solved it with an algorithm better than O of n log n. All right, that'll do it for LeetCode 347.